Welcome back to the session on Applied Mathematics 1 by KT to AT Tutorials. In this session, we will start with one small topic called fitting of curves. One question of either 4 or 8 marks is asked in each exam. So preparing this topic will straightforward give you those many marks. So let's start with that topic. Curve fitting is a part of statistics. It is the process of constructing a curve that has the best fit to a series of data points. Many times we have large data available which is dependent on certain variable called independent variable. For example, literacy rate of people in a certain area per year. Here, year will be independent variable and number of literate people will be dependent variable. Our aim will be to check the progress of literacy rate, whether it increases linearly, parabolically or exponentially. In our syllabus, we are going to deal only with fitting of straight line and fitting of parabola. There are various methods of fitting of curves, among which we are going to use method of least squares. The method of least squares assumes that the best fit curve is the curve that has the minimum sum of the deviations squared from a given set of data. So for example, if we have various data points like x1, y1, x2, y2 till xn, yn, here x will be independent variable and y will be dependent variable. Let us assume that the fitting curve fx has the deviation error d from each data point. So the method of least squares has the property that sum of squares of those errors will be minimum. Now let us have a look on fitting of straight line. In these slides, how equations are obtained using principle of least squares is given. It is not expected in exams, but for understanding purpose, you can have a look on it. The highlighted equations are very much important while solving problems. Now let us see the first problem. It is asked to fit a straight line to the following data with x as independent variable and predict y for x is equal to 1970. To solve this problem, we will arrange the table in this format. We will write the given data of independent variable in first column. Then we will find the middle number, that is 1967 in this problem, and we will subtract that number from each of the independent variable. This will be our column number 2. Summation xi hence will be equal to 0. Now we will write yi as per given data. This will be of dependent variables. Then we will multiply column number 2 elements by column number 3 elements, and this will be our column number 4. We will also square column number 2 to get our fifth column. Then we will write sum of each elements in column number 3, column number 4 as well as column number 5. So these values will be used to put in the equations that we have seen in earlier slides. Now equations are written once again. We know these values: summation yi, summation xi n, summation xi yi, summation xi, summation xi square from the previous table. So we will substitute these values and we will generate two equations. We will solve them simultaneously to get unknown values of a and b. So once values of a and b are known, our problem is solved, because then we will substitute these values in the equation y equal to a plus bx, where small x will be equal to capital X minus 1967 in this case, because we have seen in the previous table. So then we can find out the value for x is equal to 1970, because we will be able to substitute that value in this equation, and then we will get the answer y equal to 226.5, which is approximately equal to 227. Now let us have a look on fitting of parabola. In previous slides, we have seen how equations for fitting a straight line are generated. On similar lines, we can find out equations for fitting a parabola. Kindly note these equations as they will be useful while solving problems, we can see that while fitting a straight line, there were two equations and two unknowns, and while fitting a parabola, there are three equations and three unknowns A, B, C. So our aim in solving this kind of problems will be to find out unknowns A, B, and C. It is asked to fit a curve y equal to ax plus bx square for the following data. As we can see, this problem is of fitting a parabola because this equation is of parabola as degree is 2. We can see here the table is of similar kind as we have seen while solving a problem of fitting a straight line. Only difference is certain columns are added like xi cube, xi raised to 4, xi square yi, and it is obvious because here unknowns are 3. So to find these three unknowns, we need this extra data. On similar basis, we will find summation of all these elements and we will write it at the bottom. So values which we have found will be substituted in these equations and we will get three unknowns. Then we will solve them simultaneously to get values of A, B, and C. Here A is equal to 12.285 and C is equal to 0.4. So on substituting these values, we will get y equal to 12.285 plus 4.9x plus 0.4x square. Here small x will be replaced by capital X minus 3.5 and equation will be further simplified to get the answer of y equal to 2.11x plus 0.4x square. So if it is asked to find y for next value capital X equal to 7, we will substitute 7 in this x and we will get the answer of y. So with this we have finished fitting of curves. It is very simple topic, but care must be taken while performing operations like addition, multiplication and substitution, because the question on this topic is like getting bonus marks. So you should not avoid this question. Next time we will start with new and interesting chapter. Till that time, bye bye.